Okay, Go Math 7-1. This is Unit 7, and we're talking about exponents. We're getting into algebraic expressions here. So when we talk about an exponent, there are first two things that we need to define. So for example, I had 2 to the third power. 2 to the third power. Well, I have two parts to this expression. I have this part here, which is called the base. And then this part up here, which is called the exponent. So again, you can think of the base being the number that this is sitting on, and this is the part that's going to be multiplied by itself. This exponent, x is something that's out of, it's above, it's beyond. The exponent tells me how many times I'm going to multiply 2 by itself. So if I were to erase that, and I would go back to 2 to the third power. So this is a power, right? On my calculator, I would put 2, and then there's a button that's a caret, and then a 3, and an equal sign. So on my calculator, it's pretty easy to check my work. What I'm actually saying here, though, is that I have 2 multiplied together 3 times. That's where that exponent comes in. It's a number that's being multiplied over and over again by itself. So this is a shortcut. And what I find is, this is one of the biggest things that people are going to get wrong, is they're going to look at this and they're going to say, well, that's 2 times 3, and that's 6. Or I have 3 2's, and that's 6. That's not the case. I'm multiplying 2 by itself 3 times. 2 times 2 is 4, times 2 equals 8. So again, 2 to the third power is 8. So if I were to look at another one and just say, well, 3 times 3 times 3 times 3 is 3 to the fourth power. And that would be 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. This is not 3 times 4, or 12. And because of that, I can't say that 3 times 4, or 3 to the fourth power, is the same as 4 to the third power. Remember before, with our associative commutative properties of multiplication, we can kind of mix these things up. I can't do that anymore, because this is 4 times 4 times 4. So if 3 to the fourth power up here is 81, 4 times 4 is 16, times another 4 is 64. So they are not the same thing. Okay, so I have a base, which is this number down here, that's my big number, and then I have an exponent on top of it. So take a look at our book here. Excuse me. We have a table over here that shows the number of bonuses a player can receive in each level of a video game. Use an exponent to write the number of bonuses the player can receive at level D. If I move over to this side, we see level D is 3 times 3 times 3 times 3, which is 3 to the fourth power. So I take all of this and just shrink it down a little bit. Makes it a little bit easier to work with. Let me just jump ahead, and we'll try breaking one out in what's called repeated multiplication. So here it says repeated multiplication to write 10 to the third power. Well, 10 to the third power is the repeated factor of 10 3 times. So it is 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So this will come back around when we do scientific notation. We start moving some decimals around. But 10 to the third, remember, is not 10 times 3 or 3 times 10. It's 10 times 10 times 10. So 3 times. That's where my exponent comes in. One more for good measure, and I'll just jump ahead here. And yeah, let's try 20 to the second power. So 20 to the second power is 20 times 20, because it's 2 times. So what I end up with is 0, 0, 0, 2 times 0 is 0, 2 times 2 is 4, and of course the answer is 400. Now, as an added bonus, I'm going to throw in here, what happens if I had 2 to the first power? 2 to the first power, well, that's just 2. Because how many times am I writing 2? 1. But the part that really stumps some people, and we can talk about this a little bit more in future videos, is when I have 2 to the 0 power, they want to say, well, it's 2 or it's 0 because I'm multiplying 2 times 0. But that's not exactly what I'm doing here. Anything when multiplied to the 0 power is just 1. So again, exponents, we'll go a little deeper into that in future videos, but again, exponents, we have a base, which is the large number. We have an exponent, which is the number up top. And the exponent tells us how many times we're going to multiply the base times itself, which of course will give us our larger numbers.